So we're going to get into bending moment diagrams. So this time a bit more logically. I'll do my wee recap at the start instead of at the end. But what we're talking about now is bending moment. And so I want to think about a few things here. So the terminology can be a bit confusing. So what have you got first, going right back to week 2 or something like that? The moment of a force is just if you apply a force to an object, it wants to turn it like that. That's the moment of a force or a moment. Or sometimes we might end up applying two forces in opposite directions. Let me just see if I can find another one of these. So two forces, opposite directions, parallel, and that's a couple, and that has no net force, but it also wants to turn that thing, so it's applying a moment. So we've got moment, couple. Sometimes this is called a pure moment because you could do different forces at different lever arms and get the same answer, and so you would just draw that with one of those, and that would be the same thing. Now, so that's moments of a force, and then a concentrated moment or a couple. Bending moment is a different thing altogether, so you've got to be a little bit careful about that. Bending moment's an internal force. Different altogether is probably not fair. It's related to it, but you're describing something different. A bending moment is when you've got an object like so, and you apply a couple at each end, and it tends to sag like that. That's a positive bending moment. Or you've got something with couples at each end, and it tends to hog, so that would be the upwards direction, tends to hog, that's a negative bending moment. So bending moment is about the forces, the internal forces, whereas moment or couple, that's about external forces. It'll become clearer as you do more examples, but just be aware that the terminology can be a little bit confusing. So just try and keep them separate in your mind, these things, when you talk about a moment of a force, a moment, a couple, and bending moment. It's all about internal forces. So bending moment is about curvature. It's about things curving. So, and it stretches the squares at the bottom, squashes them at the top. So you get tension at the bottom, compression at the top for when you've got a positive bending moment, or you've got tension at the top and compression at the bottom when you've got a negative bending moment like that. So I've done the same thing again in Inventor. Now to see moments, can I shut this now? I think I haven't done failures. And so bending failures, and so I can't get this to fail, to be perfectly honest. It's too plastic. It can just stretch. But we can show you some bending failures. So there's a little match. Bending failure, you can see it's starting to curve. If this direction was upwards, that would be a hogging moment. And so it's starting to curve, and that's the bending failure. Now it's failed in bending. Doesn't always have to be that catastrophic. Piece of cardboard. Let's do a sagging moment this time. Sagging moment might be easier to do it this way. Sagging moment would be this way, and it's kind of yielded this time. Okay, so it hasn't completely snapped, but it has lost its strength. Okay, so that's a bending failure. And so the reason we're drawing the shear force diagrams, bending moment diagrams, is we'll know the strength of these beams. We'll know that its bending moment capacity is something or other. We draw on the shear force of the bending moment diagram to try and find out where the maximum moment is, or the maximum shear is, and then we check that against the capacity of the beam, and then we know our beam is strong enough. You do some more detailed calculations for a design engineer, but if you're looking at something like construction management, you'll be interested in just predicting or just deciding what size of beam you should buy, and then you'd leave it to the design engineers to check it. So it might be for costing or something like that, or you might be checking on site. You might look at it and go, that beam looks a bit thin or a bit small, and you want to check it. And so that's what we're trying to get to. In this course, though, we're just drawing the bending moment diagram, shear force diagram. Now, so I've drawn another beam, or grabbed another beam. This is a UB this time, remember, the UC, so universal column I used last time. It had great big flanges on it, so it's called an H-beam. This is a universal beam this time. It's got slightly smaller flanges compared to the height, and so it's sometimes called an I-beam. But again, it's got flanges top and bottom, and it's got a web joining them together. So these are the flanges, this is the web. And then again, on this diagram, I'm just showing where there's high stress. And so there's a high internal forces. This is just a bearing stress, this one. It's not related to what we're doing at the moment. Now, to see bending becoming critical, we tend to look at long, shallow beams. So it's got quite a long span. I've got 3 spans here. So I've got support here, support here, support here. I'm applying, I think I've put on quite a big load. I think it was about what have we got? 100 kilonewtons. So it's not that big. So it's 10 tons I've got on that in 2 places. And so let's put the stresses back on, or let's see where we're at. And so what's going to happen here? Oh, well, let's just have a look. So that's the actual. Again, you can hardly see it. These are rigid bodies. But if you were to exaggerate that, why is it not playing? Let's just go back to the static analysis. And just switch back on the stresses, otherwise it won't let me change the exaggeration. If we exaggerate it, the exaggerated deformation of the beam is like so. Now, this is where we get to an unusual thing about bending moments. Usually, we draw bending moment diagrams positive as downwards. And I'm going to grab this and I'm going to show you why we do that. So as if there wasn't enough confusion around signs, here's another one for you. I was thinking about not adopting this convention, but it'll get confusing later if we don't use this convention now. So let me just chuck this in somewhere and we'll have a look at it. So that's the shape of the beam, exaggerated, very exaggerated, but that's the shape of the beam. Now you remember that a positive bending moment looks like that. So it's sagging as a positive bending moment. And to create that, you might have a couple at both sides to make it like that. And so sagging, so that one is positive, and hogging, like so, going that way. Got to draw those the right way around though. So hogging, you'd have moments in the other direction like that. That's hogging, and that's negative moment. It's a negative bending moment. The reason we draw things on with positive downwards, so if we were drawing a diagram of this, we'll get into how to draw, we'll get into how to draw this diagram later. But the magnitude of the bending is all about how curved the beam is. And so if you look at this, it's not very curved at that end, but as it comes down through here, it's getting more and more curved. Then it comes up this way. It's almost straight again here, not too much curvature there. It's almost a straight line, that top and bottom flange. But then as it comes over here, it's getting more curved again. That's what bending moment is all about. It's about the curvature of this beam. Comes down, not so curved, gets near the load, very curved, comes back up, not so curved. By the time you get to the support at the end, there's not too much curvature. There's a little bit of curvature going the other way because I fixed these. It's not a pin. It's not the proper thing. If it was a pin, there'd be no curvature because there'd be no moment. Pins can't take moment. So if we were to draw the bending moment diagram of this, looks like the curvature here is pretty much like the curvature here. And I'm just going to check that just to make sure I draw it kind of half sensible like. Let me just drag this back around again. So that, yeah, in fact, it's a little bit higher. Doesn't matter. Don't worry about what I'm doing there. I just want to draw it half decent. Sorry about the coughing. I've still got this cold, unfortunately. So if we wanted to draw the bending moment diagram, we know that sagging, so this shape, is positive. And so if we were to draw positive upwards, we'd end up with a bending moment diagram that looks like this. So it would be going positive. And then here, it's hogging. And so that would be negative. And so the bending moment diagram might come down something like that. And then it would go back up. I'll just do it by hand. It would go back up to here because there it's negative again. It's sagging. And then you come back down maybe to 0. If it was a pin, it would come back to 0 at the end if that was pinned. And so you'd end up with a bending moment diagram like that. Nothing wrong with that, but it gets a bit confusing because when we're sagging, the moment's going up the way. And when we're hogging, the moment's going down the way. And so what we do is instead of drawing moment upwards, we draw positive moment downwards. That means, I'll just do it by hand so it's a bit quicker. So we're going to have a positive moment here, which is downwards. And so it's I know it's a straight line because it's a point load. We'll get to that in a minute. Here, we're going to have a negative moment. It's hogging at that point, so it's going to be up here. And it's going to come back down again. It's going to go back up. Okay, so this time positive here because it's sagging, positive downwards, and then back to zero. And what we get is a bending moment diagram that somewhat resembles the D-form shape of the beam. Now remember, the moment is not telling you deformation. It's got nothing to do with this distance. It's just about how curved this beam is. That's what the moment's telling you about. But nonetheless, it's more intuitive to see it like this than to draw it the other way up with moment positive upwards. Which begs the question, is why is sagging positive in the first place? Why don't you just make sagging negative? It's because most beams are something like this, simply supported beam, and usually you're going to get a sagging moment. And so the moments over the top, you get them a lot actually, but they're not quite as common. You don't get quite as much positive bending moment as you do you don't get quite as much hogging moments as you do sagging moments. And so they decided to make this positive so you don't get lots of negative numbers when you're doing that. Then they got to this and went, oh, well, that's a bit messy. And so then they decided, we'll just draw positive downwards. And that way, this diagram kind of resembles what the beam is doing. Hope that makes sense. You've got to try and keep all these things clear in your head. So, therefore, we're moving on now, and we'll have a look at our first example of drawing a bending moment diagram.